Sir, good afternoon, sir. Sir,
hello, good afternoon, good morning.
Yeah, here it's good afternoon. In UK, it's morning time, right?
Yeah, that's right.
Yeah. So I think, shall we start?
Yeah, that's fine. Yep.
Yeah. Can you interact with Professor Ravi, sir? Professor Ravi, sir, in the line.
Hi. Good morning and good afternoon, Ravi.
Yeah, good afternoon. Good afternoon. How are you?
I am fine, thank you. And you?
Yeah. So we are doing fine here. So yeah. So I couldn't attend your first lecture.
It's all right.
Yeah. So I heard that
something application.
Yeah. I heard that your lecture was more useful for the students. So I have so many commitments, so that I couldn't be able to attend your lecture.
It's fine.
Yeah.
It's just the application. I was talking about the application where we can use these OLED and QLEDs. That's for the display, for the entertainment mainly.
Okay, fine. Ramalingam, the second lecture is from Dr. Manivannan, is it right?
Yes, sir. Actually, first 2 hours by Kumaravel, sir.
Okay.
And final lecture by Manivannan, sir.
Okay, fine. So now you can start the proceedings. No issue. Huh?
Yeah, I think Professor Manivannan, sir, in the line. Can you speak, sir?
Hi. He's in the line.
I'm here. I'm going to listen to Kumar first and see.
Yeah, hello.
I'm good.
Manivannan, sir.
How are you?
Yeah, fine. So we are doing extremely well. Yeah. How are you?
We are good. It's better, and I'm looking forward to listening to Kumar first, and then I'm going to give my talk.
Okay.
Okay, we can.
Okay, thank you, guys. We will get in our today's business.
Yes, sir. Shall we start, sir?
Yes.
Yes, sir. Recording. Yes, sir. Sir, Ravi, sir, shall we start now?
Yeah. You can start. You can start now. Yeah.
Just a minute, sir. I will start the recording.
Yeah.
So, welcome all the participants, dignitaries, and eminent speakers of the 1-week virtual program on International Short-Term course on 2D quantum dots, synthesis and application in electroluminescence, diodes, sensors, and solar cells. So, we are the fourth day of 5th August 2021. So in this session, day 4, we have 3 lectures. So first 2 lectures, which are going to be handled by the device engineer Muthulingam Kumaravel, and followed by Professor Nadaraj Manivannan from Brunel University. So the first talk for this afternoon session is going to be on topic of device physics of 2D quantum dots, diodes, transistors, electron hole transport, and followed by device characteristic such as making of device manufacturing and characterization. So in this lecture is very special and very specific that how we can able to make in the point of device making. So here we have an expert today, is very quite kind enough to approach us, the device engineer Muthulingam Kumaravel. So people are, if you are interested, you can directly interact at the end of the session. So meanwhile, you can note down any questions or queries or suggestion, whatever. And this lecture will be, I hope that this lecture will be very useful and very informative, because we are lacking about this device side. So this lecture is going to be only on consulting of device. So how we can make LEDs and other electroluminescent diodes. So thank you so much. On behalf of Brunel University and Alagappa University, I thank you once again for all the faculty members, research scholars, PG students, those who are joining in this Google platform as well as in the YouTube. And then I also thank the participants, and those who are the important announcement, those who are in the YouTube. If you have any questions or suggestion, please write it in the chat box, so that we will convey into the subject expect today. So with this introduction, I will further no delay, I requested Professor Muthulingam Kumaravel to deliver his lecture. Over to you, sir.
Thank you very much. Can you see my slides, please?
Yes, sir. Yes, sir.
One?
Yeah. Can you go for next slide? Move on to next. Yeah. Yes. Fine. Perfect.
Okay.
Yes, sir.
Thank
Excellent.
you.
Yes.
Thank you. Welcome to the short course conducted by Alagappa University with the Brunel University. My name is Muthulingam Kumaravel. I am working at Brunel University as a device engineer. I have a experience in 20 years making devices and characterizing. And today I'm going to share with my knowledge and experience here. First one, we are going to talk about transistors, diodes, and the structure of the OLEDs and the QLEDs. Yeah, the first I move to the first one, the transistor. What is the transistor? It's just one type of tap, you know, the water tap. So it has like a source and drain. So I just change my pointer first. Okay. Right. This is source and drain and the gate. There are similar type of modeling is in the transistor. That's a source, drain, and the gate. So transistor is a semiconductor device. It has both conduct and insulate electric current or voltage. So transistor is basically it's doing the switching switch and amplifying that electricity. So this is actually regulate the electronic flow of signals. So the basic structures of the transistor is, there are four basic structures there. You know, the gate, source, and drain. So if the gate is on the top, we call this the top gate transistors. If the gate is in the bottom with the substrate, that's a bottom gate transistors. Then the drain and source normally connected with the channel, and the gate and the drain and source divided by the insulators normally. So if the carriers attacked by the gate is called stagger. If carriers connected with the drain and source, that's called coplanar. So there are the four different structures of the basic transistors, these ones. So why we need the transistor? We are working on the display. So the active matrix display actually need the transistor. So normally the displays has many millions of pixels and subpixels. So every subpixel actually is driven by the transistors. So the essential components of the transistor is driving the pixels, subpixels. So our application mainly for these liquid crystal displays, organic light diodes displays, and electronic paper displays, and the mini LED displays and the macro LED displays. So these pixels actually, this TFT, what actually is doing, every color has 256 different gray levels. So it can be easily that TFT is switching to the different colors. So we can't make different colors actually. We normally makes the 3 different colors, is a red, green, blue. But this transistor, it can make the gray levels. It is defined that gray level from dark red to that light red by this transistor. So this actually we need this transistor actually for the active matrix displays. Active matrix displays. So these are the active matrix displays, actually the small displays and the medium displays, which is normal laptops, and the large displays, the computer monitor and the television. So these are the displays really work with the TFTs, thin film transistors. Yeah, we will see the difference with metal oxide and the thin film transistor. So the metal effect MOSFET is normally they use the semiconductor material is on the substrate that silicon wafers, they use it normally. But here in thin film transistors, normally use the plastic or the glass. Then we make the thin film of the semiconductor materials. We can get, when we use MOSFET, that there are size limited, but we can get ultra high resolution on there. But this TFT thin film transistors, we can make larger because we need a larger for this, the display, because the displays become 85 inches television. So we can easily to make this thin film, use this thin film transistor to drive the displays. So thin film transistors, that is a type of semiconductor MOSFET, but this is it has a metallic contacts and the dielectric layer over an insulating layer. You know that the difference, the gate and the source and drain, there's a divided by dielectric layer. So there are 4 different types of thin film transistors there. That one is amorphous silicon transistor, then LTPS, there's a low temperature polysilicon transistor, then organic thin film transistor, and oxide thin film transistor. So application of these transistors, the small display like mobile phones, they're using the LTPS, the low temperature polysilicon transistor. Then the medium size, it can be used amorphous silicons, oxide thin film transistor or LTPS being used. But the large size displays, we use amorphous silicons or oxide thin film transistor. And the flexible active matrix OLEDs, we use the low temperature polysilicon or the oxide thin film transistors. And the flexibly the electronic paper, we need an organic thin film transistor. So this is some the summary of that alpha silicon thin film transistor. It actually we need to use high temperature to anneal to make this amorphous film. So it might have some defects. Then they found out if they introduce some hydrogen, they can make the good amorphous silicon transistors, which can be used for the large the liquid crystal displays or the QLED liquid crystal displays for these ones. And the low temperature polysilicon one, this we are crystallining, annealing to polycrystalline that silicons. It can be used for, there are the 4 different type of annealing method. This can be used for small display, like mobile phones and the watches. We can use this thin film transistor to drive that pixels. And this is the organic thin film transistors. This is actually used for any that flexible or highly curved LCD liquid crystal display televisions, it can be used easily, these organic thin film transistors. Here we use small molecules of the polymer material we make. Actually small molecules you can evaporate, vacuum thermal evaporation to make a film, and pentacene like a polymers. Pentacene is also the small molecules, and the polymers normally we can use solution processed or printing method to make the organic thin film transistors. And oxide thin film transistors, which is mainly the 15 metals can be used to make these thin film transistors. It is normally used small to the large displays. These are some organic P type material and N type material we can use to make these organic thin film transistors. Now we see the difference between the active matrix and the passive matrix. What is active matrix means each pixel is driven by the thin film transistor. But passive matrix, actually we don't need the thin film transistor.